Hello, Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Zamzuri bin Salmi from Cohort 8. Today I would like to present about business statistic. I prepare for Sir Muhammad HAZEEM bin Muhammad SIDIK. That's my group member. Me, Muhammad Zamzuri bin Salmi, matric number A21B0039AP, and my member in groups Nik Nomi binti Nik Ayub, matric number A22L00006EP. Okay, look at the table of content I would like to present to you, sir. We have four table of contents to present to you. It's number one is data descriptions, two graphical representations using software, three statistical analysis, 3.4.0.1 numerical descriptive measure, 3.0.2 hypothesis testing, 3.0.3 correlation analysis, 3.0.4 confidence interval, and the last number 4 prediction modeling. Okay, it's number one is data descriptions. What's the data description I would like to do? It's number one is the data is set is about 392 vehicles to compare the vehicle performance according to its variables. The variable of the data sets are the fuel consumptions liter per 100 kilometer, the travel distance kilometer per liter, and the total number of engine cylinder, the total horsepower, the weight, and the brands. There are two kinds of variable which are qualitative, quantitative variable. First, for ungroup data, brands, number of cylinders. You look at that. The brands have Opel, Datsun, Citroen, Ford, Honda, BMW, Mercedes, and Audi. The frequency from 82 to 13. The next of table, number of cylinder and frequency. You can see the two of table of there. Okay, this is a liter per hundreds, divide by 9 class using class interval 4.2. The next table is KPL divide by 9 class using class interval 0.21. Okay, so you look at that, the next of table, horsepower divide by 9 class using class interval 4.2. And the next table is weights divide by 9 class using class interval 0.932. Okay, then that's the graphical representations using a software. Okay, that's there's a class win equal to 0.99, lower boundaries equal to lower limits negative 0.5, upper boundaries equal to upper limits plus 0.5, midpoint equal to lower limits plus upper limits divide 2. There's a little bar chart of fuel consumption using the class midpoint. And other table with the class midpoint, frequency, lower boundaries, and upper boundaries. These are bar charts on frequency and liter per hundreds. Look the most used vehicle brands. We like to cak apa yang bulat ni, lupa pula. Okay lah, kita teruskan. Same test brands: Opel, Datsun, Citroen, Ford, Honda, BMW, Mercedes and Audi. Brand relative frequency, and frequency. There's a number of cylinder in vehicle which affect vehicle performance. This is a bar chart. You can add the frequency and number of cylinder. The weight of vehicle. There's a tick chart. Tick chart have a cumulative frequency and weight. Look at the table of their class, frequency, upper boundaries, and cumulative frequency. There's a bar chart for weight of vehicle, frequency, and weight. Look the table beside there. We have class, midpoint, lower to upper boundaries, frequency, lower boundaries, and upper boundaries. Okay, next is statistical analysis using software, numerical descriptive measure, hypothesis testing, correlation analysis, and confidence interval. Okay, so this is a numerical descriptive measure. Number one is a measure of the central tendency. That's mean, median, and mode. For example, basically we use mean, median, and mode. And number two is measurement of positions. Measurement of position. Quartiles divide the data set into 4 equal parts. Decide and divide the data set into 10 equal parts. And percentiles divide the data set into the 100ths equal parts. 3. Measure of variation, range, variance, standard deviations. Okay. The numerical descriptive measure, various numerical descriptive measure brands. Look at the two table. And table number 1, look at the brand Audi, Mercedes, Datsun, Ford, BMW, Citroen, Opel, and Honda. In that table, you have frequency, relative frequency, cumulative frequency. The variance brands, frequency, X and Y, X2, and brands. You can look the table. Okay, there's various numerical descriptive measure liter per hundreds. We have a class frequency F, midpoint X, F at cumulative frequency, lower boundaries and upper boundaries. The class 2.15 to 4.39. That's a frequency F over than 300. There's a midpoint Fx. And also the variance you can see in the table under the under the table of out there. Okay, various numerical descriptive measure. You can see the KPL data, and the under the table is a variance for KPL. Next, the various numerical descriptive measure cylinder, the number of cylinder, grand total, frequency, relative frequency. Here you can see the two table under the table data cylinder, see the medians and variance. Look at medians. We have a number of cylinder 5, 3, 6, 8, and 4. Frequency 3, 4, 83, 103, 199, and grand total we got 392. For variance, number of cylinder 3, 4, 5, 6, and 8. Frequency SX for 199, 3. 83, 103, and grand total you get 390. For X2 you get a grand total 52,124. Okay, so these are various numerical descriptive measure for horsepower. You look at that, the class, frequency, midpoints, SX, FX, cumulative frequency, lower boundaries, and upper boundaries. The variance of the horsepower have a class. You get the frequency as F, midpoint X, X2, FX, and FF2. For various numerical descriptive measure for weight, you can look at the table of data for weights and variance under the weight table. For 3.2 hypothesis testing using sample t-test and ANOVA. Step 1, state null hypothesis and alternate hypothesis. Look at the formula. HO U1 equal to U2. HA U1 not equal U2. Step 2, state the level of significance A equal to 0.05. Step 3, output SPSS. Hypothesis testing using sample T is ANOVA. Step 4, decision rule. Reject HO if T more TA divide 2 dF. For critical regions, T 0.05 divide 2.26 equal 2.056. For correlation analysis, step 1, for hypothesis, actually, HO, there is no correlation between brands, liter per 100 kpl, cylinder, horsepower, and weight. H1, there is a correlation between brands, liter per 100 kpl, cylinder, horsepower, and weight. Step 2, significant level. A equal to 0.05. Step 3, SPSS output. 3.3 correlations. You can see the table of correlation. We have brands, liter per 100, kpl, cylinder, horsepower, and weights. For the notes, correlation is significant at the 0.01 level, two-tailed. There's next correlations. For the net correlations is significant at the 0.05 level, two-tailed. Okay, correlation analysis. That's a step 4 decision rule. You look at the formula, and we can get the answer -3 from 8107112046181587E -07. step 5 decision, the low value show that's the correlation between KPL and cylinder span in the class is very low. Confidence interval. The confidence interval is expressed as a range typically with an associated confidence level, often represented as a percentage. For example, 93% confidence level. This confidence level indicates the probability that the true population parameters lies within the calculated interval. Confidence intervals are valuable in business statistics as they provide a range of plausible value for the population parameters, allowing decision makers to assess the reliability of the estimates and make informed business decisions based off the level of confidence they require. That formula is the x plus ZA2 plus divide 2 S and N. Using where the significant level equal to 1009 and you can get the answer 70 and 36 and 66.44. The confidence limits range from 70.36 to 86 and 44. About 65 about 95% of the similarly constructed interval include the population's parameters. The prediction of modeling. Multiple linear regression is the most common form of regression analysis. It allows us to use several variables at once to explain the variation in a continuous dependent variable. It also allows us to isolate the unique effect of the one variable on the constants dependent variable while considering that other variables are affecting it too. Thus, every value of the independent variables for potentially related to the dependent variable. Hence, the model is represented as y equal to b0 plus b1 x1 plus b2 x2 plus b3 x3 plus b4 x4 plus e, where y is the value of the dependent variable, bo, b1, bk are parameters, x1, x2, sk are known constants, e the error terms. There's a summary output, a regression statistic. You look at that, predict a vehicle for 83 cylinder, 2.99 weight, y equal to b0 plus b1 x1 plus b2 x2. Then you can get y plus y equal to negative 0 from 404 plus 830226 plus 2.9913 1.327. Then you can get the answer 22.32173. Finally, we get the concluding remark. You can see that concluding remarks. Use it fits use it six field, which is an interpol 100 kpl cylinder, horsepower, weight, and brand. Class interval: frequency, cumulative frequency, relative frequency, midpoint, upper boundaries, and lower boundaries to complete the graphical representations. Value are different between the manually calculate and the SPSS system. They are different is mean, median, mode, standard deviations, variance, quartile 1 and quartile 3. For some of the this value, the difference between the manually calculate and the SPSS system is very large, especially for standard deviations and variance. But for some, the difference is small. In contrast, there are no difference between the manual calculate and SPSS output for the range, maximum and minimum data of the data entry. 5 main steps, which are state null and alternate hypothesis, significant level, SPSS output, decision rule, and decisions. Hypothesis testing use t-test and ANOVA table with a 5 main steps, which are state null and alternate hypothesis, significant level, SPSS output, decision rule, and decision. Correlation analysis using the SPSS tool to solve the confidence and interval. That's all for now, sir. Thank you. I feel very sorry for my friends, Nomi bin Ni Ayu. He's very busy, and I just be present for she. She's very busy for elections. We get the for election in the Cempaka for for election day. If you give the full mark ataupun sir nak bagi dia separuh ke, nak bagi sikit pun tak apalah, asalkan dia dapat juga markah sikit. Sekurang-kurangnya dia tak gagal lah, sir. Dan saya cuma membantu dia untuk election dia nanti. Itu saja. That's all for now, sir. Thank you very much. Thank you for giving me time. Thank you for hear my presentations. Thank you, sir. Thank you, sir, for teaching me for this semester. I very appreciate, so it's very nice to me and for all students. I'm very proud to be your student, sir. Thank you, and Assalamualaikum warahmatullahi wabarakatuh.